Joining me now is Kenny Todd, the Operation Integrations Manager for the International Space Station. Now, Kenny, first off, thanks for joining me. So you were here last week when we were just starting to look at the problem and analyze it. Why don't you just give me kind of an update, what happened over the weekend, and where are we now?
Sure, you bet. Let's see, when we talked last week, at that time we were still pretty fresh into this particular issue, and the flow control valve was really the focus of our effort in trying to recover it. And since that time frame, it's become apparent to us through all the evaluations that we've done that the flow control valve was not available to us to continue regulating temperature in this particular ammonia loop. At that point, we started expanding out from that valve, looking at the rest of the system and looking to see if there's other ways that we could provide some temperature control into that loop. And we did find what we term an isolation valve that is just upstream of this particular flow control valve on the radiator side. So in the current way it was being used, it was a binary valve. It was either open or closed for the ammonia coming from the radiator. And so the team did a great job at looking and seeing, can we use that particular valve as a regulator, if you will, to restrict the flow coming from the radiator, and by doing that, that would help to bring the temperature in the loop a little warmer, and hopefully to the point that we can start to reintegrate it back into the bigger thermal control system and control some of these loads, the heat loads inside the station. We've been focusing on that for the last couple of days. I think we're taking a valve and using it for a different purpose than what we'd originally intended. So we didn't have a controller in place to go in and basically control this valve at the small increments that was originally planned for. We've been working with the vendor, the hardware vendor for this particular valve, and they say absolutely it can be controlled in the manner that you want. So what we've been doing for the last couple of days is trying to put the right systems in place, software on the ground, commanding capabilities, if you will, to try to allow us to be able to control that valve in a manner that allows us to stop it where we want to stop it. And so as of this morning, the team is continuing that effort. It seems like as we move along and learn more about this valve and the way to command it, it's clear that we have to operate it in very small increments on the order of 100 milliseconds, and putting the capability in the control center here to allow us to do that has been quite an effort over the last 2 days. And so this morning the team is going through that effort to command this valve and do it in small increments. And so that's it's kind of a turn the valve, watch it for a little bit, see what the temperatures do, see what the flow rates do, and we're having some success with regard to characterizing the system using this particular method. Whether or not it will be enough to allow us to put heat loads back onto the system from other parts of the loop, we can't tell yet. Given that we're kind of developing a new philosophy for how to manage the loop using this valve, along with some other parts of the system, I would say it's still very much in work, and whether or not we can pull it off, I would hazard to give you any kind of percentage at this point. But the team is working very hard to do that, and again, having some degree of success this morning in trying to at least characterize the system a little better with this particular valve. So we're pretty excited about that, and we'll see how things go the rest of the day.
Okay, and just for a quick snapshot, right? So what condition is the loop in right now? Like, what kind of loads are you guys actually placing on it? What systems are on a different loop, shut down?
Sure. Relative to this loop, we call it Loop A. There are some external loads. We have some what we call a main bus switching unit that's external to the station that has to be heated. There's some cold plates out there that have ammonia running through them, but it's all just external equipment that's being right now cooled or warmed through this particular part of the ammonia loop. At some point, whenever we can characterize this operation of this particular loop a little bit better with this new valve modulation philosophy that we're trying to use, then we can get into the point where we can talk about introducing that ammonia into the heat exchanger at the Node 2 or on the U.S. lab, and start trying to draw some of the heat loads off the station. So we're not quite there yet, and so at this point we're still basically from a Loop A standpoint at the same place we were last week in terms
Okay.
of the what the ammonia is actually touching at this point.
Okay, so the team's continuing to work on this, very creative, inventive fix to try and get the loop, at a much more functional level. Would that be a permanent fix, or would a spacewalk? I know the spacewalk, the astronauts are preparing for it this week, but we don't know for sure yet if that's going to happen. Would a spacewalk still be necessary to bring this back up to kind of like its full, 100% functionality?
Well, whenever we figure out just how hard this, we call it limping along. Sometimes you can figure out a way to limp along for 2 months, 4 months, 6 months, and a lot of that's going to be driven by how operationally complex it is to try to live with a particular issue.
Gotcha.
And until we understand exactly, how this system gets characterized and what it means to try to operate with the limits that we'll have to operate within, given this particular valve and the other options that are available to us, we may or may not be able to do that for an extended period of time. If we can't do it for the foreseeable future for an extended period of time, then we obviously got to look at other options. But clearly at some point in the future, we're going to want to go get the system back to its nominal situation with the pump module, and so it's just a matter of timing and when we do that. So that would be our clear path at some point to do that.
Okay. Well, again, Kenny Todd, Ops Integration Manager for the station. Team's continuing to work here in Mission Control to try and get that loop back up to where it was before the issue cropped up last week. Kenny, thanks for giving us a quick update. Really appreciate it. We're going to continue to follow along.
Thank you.
Thanks.